Welcome to Photon Academy. In this session, let us see the physical quantities which are having the same dimensional formula. Here, all the energy related terms having the same dimensional formula. Example, here, one, work or energy. And the second one is kinetic energy. Work or energy is here. Work or the energy is force into displacement. The force into displacement, clear, which is nothing but ml square t minus 2 is having the dimension formula. Similarly, the kinetic energy is of mv square. This is also is a non-dimensional parameter. So it is not having any kind of the dimension over here. So it is completely known as non-dimensional parameter, a constant. You can eliminate this one. So here, for the mass m, velocity lt minus 1 whole square. So finally, m l square t minus 2, which is same as that of the work or the energy. Clear? So let us see the other energy related terms. Third one is potential energy. Which is mgh. M stands for mass, G stands for acceleration due to gravity, H stands for the height. M, acceleration due to gravity is the LT minus 2. Height is nothing but again L. So final dimension formula is ml square T minus 2, which is same as that of the work or the energy. Clear? Okay. Let me take up a fourth parameter, that is the pressure energy. Pressure energy, which is nothing but defined as pressure into volume. Pressure into volume. What is pressure? Force by area. Force by the area. Normal force by the area. And volume is what? Volume is area into length. Area into length. So area goes out. Finally, it becomes that is force into length L. So what is the force dimension? ml t minus 2. Length is L. So final dimension formula is ml square t minus 2, which is same as that of the work and energy. Okay. So the fifth parameter, Let me take up is, fifth one is torque, or it is also known as twisting moment, twisting moment, twisting moment. It is simply defined as force into the perpendicular distance, force into perpendicular distance. Clear? So force, what is the dimension formula? ml t minus 2. Distance is for L. So final formula is ml square t minus 2. This is the dimension, which is similar to that of the work or the energy. Work or the energy. Okay. Let me take up the sixth parameter. That is, sixth one is rotational kinetic energy. Rotational kinetic energy. Rotational kinetic energy, which is nothing but simply off into I moment of inertia, angular velocity square. Okay, you know very well that the simple kinetic energy off into mv square, whereas rotational kinetic energy is off into moment of inertia. I stands for moment of inertia, omega stands for angular velocity. Clear? So here, this half is a non-dimensional parameter, so it is not having any kind of the dimensions. So final dimension for moment of inertia is ml square, and angular velocity is t minus 1 whole square. So it becomes ml square t minus. This is the final dimension formula. Coming to the seventh parameter, we would like to take up is the heat energy. Heat energy. Heat energy is also having the same dimension formula, ml square t minus 2. Okay, so all those parameters which I have explained here having the same dimension formula of energy, energy related. These are all energy related parameters. So simple dimension formula is ml square t minus 2. Wherever you come across energy term, blindly remember it is ml square t minus 2. Whether it is kinetic energy or potential energy or rotational kinetic energy or heat energy or simply the pressure into volume, pressure energy, or the work or simple energy. All are ml square t minus 2. Okay. Let us see some more other physical quantities which are having the dimension formula. Okay. Which are having the dimension formula of t minus 1. Dimension formula of the t minus. That is, if you want to write specifically, m to the power of 0, L to the power of 0, e to the power of minus 1. Okay, first, let me take up first quantity, angular velocity. Angular velocity. Angular velocity. Omega. So here it is simply defined as previous class we have seen angular displacement theta. Okay, theta is angular displacement, and the time period t, time, angular displacement by time. Theta is not having any kind of dimensions. So it is simply 1 and time period is t. So this is equal to t to the power of minus 1, t to the power of minus. Let us see the second one. That is, the second one is frequency. Frequency. 1 by time period. 1 by time period. So this 1 by time period is 1 by t. Again, it is t minus 1. T minus 1. And third term we take up is, that is velocity gradient. Velocity gradient, which is equal to the velocity by the distance. Velocity by the distance. Velocity by distance. Observe, velocity is having a dimension formula of Lt minus 1. Distance is L. L goes out. Final formula is T minus 1. Final formula is T minus 1. Okay. The third one, velocity gradient we have seen. Fourth parameter I would like to take up is angular frequency. Angular frequency. Angular frequency. Angular frequency is simply defined as, that is equal to the 2 pi n. Okay, 2 pi is a dimensionless parameter, constant. N is equal to nothing but the frequency term. So 1 by t, which is equal to t minus 1. Okay. Let me take up the fifth parameter is decay constant. Decay constant. We come across this in the modern physics of lifetime period. The decay constant equation is 0.693 by the half-lifetime period. Time period. Half-lifetime period. So, which is, this is having a non-dimensional parameter. So, no dimensions for this. So, 1 by t. 1 by t is nothing but t minus 1. T minus 1. The sixth one I would like to take up is, the sixth one is Hubble constant. Hubble constant. Hubble constant, which is simply defined as the recessing speed to the distance. Okay, recession or recessing, both are same. Recession speed to the distance, which is equal to the speed is what? Velocity terminology, dimensions Lt minus 1. Distance is L. This LL goes out. Finally, T minus 1 is the complete dimension formula. So all the above parameters, angular frequency, angular velocity, and Hubble constant. Okay, so remaining all velocity gradient associated with a simple dimensional formula of the T minus 1. Simple dimension formula of the T minus 1. Specifically, if you want to write m to the power of 0, L to the power of 0, T minus. Okay. Let us see the physical parameters which are having a dimension formula of m to the power of 0, L to the power of 0, T to the power of 0. That means no dimensional formula at all. Let us see the one by one. First one I am taking up is strain. Strain. What is strain? Change in length to the original length. Okay, change in length to the original length. Or simply, I can put up the change in dimension. Generalization I am doing. Change in dimension to the original dimension. Original dimension. So, change in dimension, whatever may be, it is a change in length to the original length. It is the strain. Clear? So, this completely it is having a dimension of m to the power of 0, L to the power of 0, T to the power of, because this numerator, denominator having the same length parameter. So get cancelled, thus becomes the above. Okay. The second one. The second one here is angular displacement. Angular displacement. Observe, this is a circle. This is the center. Suppose body is moving from OA to OB. This is the periphery. It is moving A to B. This is the theta. Theta is the angular displacement. Theta is equal to arc length by radius. Arc length by radius. Clear? Arc length by radius is, both are having the same dimension lengthwise. So finally it becomes m to the power of 0, L to the power of 0, T to the power of 0 is the dimensional formula. Okay. So third one I am taking up is the trigonometric ratios. Trigonometric ratios. Observe, if you take up sine theta or cos theta or tan theta or secant theta, whatever may be this, all these are ratios. Clear? What is sine theta? Opposite side by hypotenuse. Cos theta, adjacent side by hypotenuse. Tan theta, opposite side by adjacent side. So these are all the ratios having the same dimensions. So henceforth, m to the power of 0, L to the power of 0, T to the power of 0 are the dimension formula. The fourth one is refractive index. Refractive index. Again, it is defined as the mu. It is a ratio. So ratios are having again the dimension formula m to the power of 0, L to the power of 0, T to the power of 0. Okay. The fifth one is the magnification factor. Magnification factor, simply defined as the image distance to the object distance. Both are distances. Hence again, once again, distance by distance, it becomes again no dimensions. M to the power of 0, L to the power of 0, T to the power of 0. Okay. Let me take up the another one, that is here we have taken the ratios, whatever may be the ratios. If numerator and denominator possess the same unit, then dimension formula becomes m to the power of 0, L to the power of 0, T to the power of 0. You remember that in a conclusion, I'm telling, wherever energy is associated, ml square T minus 2. Wherever the ratios are there, no dimension formula, that is, it is 1. That means m to the power of 0, L to the power of 0, T to the power of 0. And the other things, wherever you come across angular velocity, frequency, and the Hubble constant, etc., those are all the T minus 1. So this is the generalization that we have summarized. Okay. So here I am concluding the session. In the next class, we will see some more parameters associated with the dimensional quantities.